Hi everyone, right, I overdid it last time, didn't I? Damn it. So this time we'll try again. Much shorter. Surds. Okay, root 90. So we already know what a surd is. A surd is something that is broken down into an irrational number. Okay, so root... No idea. Right, okay. So root 4 is not a surd because that's the same as 2. The square root of 4 is 2. Okay, so root 4 by itself is not a surd. Root 2, however, if you type that in your calculator, press equals, you'll get an irrational number. And an irrational number means it can't be expressed as a fraction. So 2 can be expressed as a fraction, can't it? Because that's the same as 2 over 1. But root 2, you cannot write that as a over b. Okay? And therefore its decimals will go on forever. Like there's no predictable pattern of decimals. So a third, you know, is the same as 0.3333. It's predictable, isn't it? So that 0.3 recurring, whereas root 2, you'll never be able to do that. So that's what a surd is, okay? So at the moment, root 90 is not a surd, but we want to put it in surd form. So to do that, again, this actually links with the a to the x to the y business. Root 90 is the same as square root of, and let's think about its factors of its factors here. So root 90 is the same as square root of, well, 90 is made up of 9 times 10, isn't it? Okay. Notice I always use brackets and not the times sign, okay? Brackets are so much better than times sign. Times sign, this actually means the cross product, which is an F, something in much higher level of maths if you're doing double maths. And it also, it just kind of looks like X, doesn't it? Anyway, so linking this to this is the same as 9 times 10 all to the power of a half, isn't it? And from our AXY business, that's the same as 9 to the half times by 10 to the half. Okay, so this is the same as root 9 times root 10, and root 9 is 3, and root 10 is not a square number, and therefore it can't be broken down any further. You might say, oh, that's the same as root 2 times root 5, but they're still surds as well. You see, root 10 is an irrational number because root 2 and root 5 are irrational numbers. So 3 root 10 is enough. Okay, you have broken that down. The second one, root 3 over root 6 over root 3. Well, at the moment this looks quite nasty, but again, if you think about the factors of 6, the factors of 6 are 2 and 3, or 6 and 1, but we're trying to break them down into prime factors, okay? Now, root 2, and as in that's a good starting point, prime factors, or anything that you can think of really, until it can get broken down. So obviously root 2, root 5 for here are prime factors, but we don't need it because root 10 already is a surd. Okay, so 6 is the same as 2 times 3, which means root 2, root 3. And you can see that the root 3 over root 3, so this is same as root 2, root 3 divided by root 3, cancels. Okay, so you're just left with root 2, which is a surd, because root 2 is irrational. Part C then, again, we've got root 2 on the bottom, root 32, well, what can that be split up into? What are the factors of 32? Well, that's the same as 8 times 4, isn't it? Yeah, 8 times 4. So root 8, root 4 over root 2. Looks a bit nasty, but no need to worry. We can do that again. You see, we can make it a little bit nicer. But what I was, well, let's do it this way first. So root 8 is the same as square root of 4 times square root of 2, yeah? And we've still got our square root of 4 here as well. So can you see straight away, again, once you've got that common factor, that root 2 over root 2, that cancels. So root 4 times by root 4, that's the same as 2 times 2, which is 4, okay? You could have looked at this, root 32 is the same as root 2 times root 16 over root 2. And again, the root 2 cancel and root 16 is 4, okay? Part 3, B, this is about collecting surd terms. So remember surds surd terms that are the same, and you can put them together. So root 48, let's do the same thing again. Let's break that down into its most fundamental components. So I always think it's good to take out 2 first. Okay, so either go for primes, or if it's even, just take out the 2 and see what happens. So root 2, root 24, plus 4. Now what can 75 be broken down into? Well, 75 is a multiple of 5. Well, you could look at it as a multiple of 5, or you could do, again, some people like to do big chunks, so I think I'll do a big chunk. This is the same as root 25 times root 3, okay? Now, let's deal with this business. This root 24, again, doesn't look very nice. That's the same as root 2, root 12, yeah? If you're just breaking it down because it's even into 2s, plus 4 lots of root 25, which is 5, and square root of 3 can't be changed anymore. Root 2 times root 2 here is 2. So at the moment we're here. 4 times 5 is 20. Now let's break down that 12 again. Again, it's a multiple of 2. So it might be helpful to take out the factor of 2. Okay, there's no definite rule to follow here. And again, 6 is even, so we can take out root 2 again. And we're here. Now, 2 times root 2 times root 2, root 2 times root 2 is 2, so 2 times 2 is 4. And actually then we can see that this initial expression can be broken down into 24 lots of root 3. So you can put them all together because they're the same surd. Part B, similar fashion then. But again, maybe with this, maybe you can spot stuff. Maybe you can spot square numbers quite quickly. For example, root 300, kind of root 100 screams out at us, doesn't it, really? 3 times 100 is 300, right? It's minus 48, you know, 24 and 2 again, root 8 and 6, you know, whatever you want to go for. Let's try the root 8 and root 6. So you're just thinking about its factors. And we've got our plus root 8 at the end. Well, that's root 2 and root 4, isn't it? Okay. So we're trying to break them down into the simplest form. Root 10 is, root 100 is 10. Root 3 minus, we've got this root 8. So let's split that up again. That's root 2, root 4. And we've got this root 6. That's root 2, root 3. Now we've got our root 2 here. And we know that root 4 is the same as 2. So that's 2 root 2. So it looks a bit hideous, but you just got to be patient with this kind of stuff. So root 4 we know is 2. So we've got 2. Root 2 times root 2 is 2 again. Root 3, and then we've still got our 2 root 2 on the end. So we've got 10 root 3 minus 2 times 2 is 4 root 3 plus 2 root 2. So 10 root 3 take away 4 root 3, there's 6 of them. And we've got that 2 root 2 on the end. Okay? Last one. Rationalizing the denominator. What does that mean? It means make the bottom rational. So as we know, an irrational number is when you've got a surd. Okay? That's one example of an irrational number. We don't want an irrational number on the bottom. Okay? It looks awful and it's not very helpful to us. So how do we make an irrational number rational, or rather a surd not a surd anymore? Well, what you can do is we can times it by itself. So root 2 times by root 2, as we know, and we've just seen, is the same as 2. And remember, that's because the indices are adding together. This is our a to the x times a to the y business. So you've got a to the half times a to the half, you see, and the powers add, don't they? Exactly the same here, so that's 2 to the half plus a half, okay? So that's 2 to the 1. So we need to make that denominator not root 5 anymore. And the way to do that then, just said it, is to times it by itself. But linking with our fractions work, if we times the bottom by root 5, we need to times the top by root 5. Otherwise, we have changed our original number, okay? So on the top, we've got 4 root 5 now then, and root 5 times root 5 is 5. So there we go, rationalized it. Okay, this second one, rationalizing this denominator, well, this is where you're going to need to use your kind of difference of two squares knowledge, okay? Why do I say that? Because we know that a squared minus b squared is the same as a minus b, a plus b. Hopefully you know that. And it has to be a different sign here. It has to be a difference of two squares. Because if it was the same sign, right, when you multiply this out, you'll get 3 terms. You'll get a squared, right? So a squared times that one out, minus ab times this one, minus ab, and minus b times minus b is plus b squared. You see you get a squared minus 2ab plus b squared. But we just want 2 terms. We don't want 3 terms. And difference of 2 squares will always give us that, okay? Give us 2 squares. And the objective is to make the denominator rational. So what you always have to do is just times the top and bottom by the opposite sign. So the numbers stay the same. So you can see you're creating a difference of 2 squares on the bottom, and the signs are different. So on the top, we get 2 times 3 is 6, and 2 times minus root 2 is minus 2 root 2. On the bottom, we get 3 times 3 is 9. Notice why we do the difference of 2 squares, because 3 times minus root 2 is minus 3 root 2. But here we get plus 3 root 2, so they cancel out, you see? So you can just straight away go root 2 times minus root 2, which is minus 2. So this is the same as 6 minus 2 root 2 over 9 take 2 is 7. So now you see the denominator is rationalized, okay? Let's try part C. So again, I'm going to ignore what's on the top. I don't care about that right now. But what I do see is I've got a surd on the bottom, and I need to make it rational. So I use my difference of 2 squares knowledge, just write exactly the same numbers, but with a different sign. If I do that to the bottom, I've got to do that to the top. Yeah? So if we sort the bottom first, so root 3 times root 3 is 3. Minus 2 times 2 is minus 4. And we know the other terms cancel out. The minus 2 times root 3 plus the 2 root 3, they cancel out. So on the top here then, timesing this out, so 3 root 3 times by root 3, right? And 3 root 3 times by 2 is 6 root 3. So on the bottom we get minus 1, as 3 take 4 is minus 1, just put that up here. And on the top we get 3 times root 3 times root 3, which we just agreed is 3, times that by 9, sorry, that makes 9. And the 6 root 3 stays. Minus 1 on the bottom is the same as just timesing everything by, that minus could just come out, can't it? So that's the same as minus 9 minus 6 root 3. Hopefully that's pretty cool for you. Okay, thank you.